So, hello, my name is Alan Daniel Cordes Munguia. My ID is 2091698, and I'm going to talk about my leap of communication competence. And it is about green chemistry, and it is more focused on like biodegradable polymers. So let's start with, because it's a lot of information. So first we have the introduction. So the introduction, it says that, well, unfortunately, pollution from traditional plastic is a major environmental issue. As you can see on that lake that is over there. So yeah, so green chemistry seeks safer, eco-friendly alternatives through innovative synthesis. So first, we need to know what is green chemistry, okay? So green chemistry, it is the design of chemical um, products and process that reduce or eliminate hazardous substances. So we have on the image the 12 principle of green chemistry. So I'm gonna talk about like a little bit of them, like fast, and I'm gonna do kind of a summary because of the time. So well, here first we have the prevention, and it focuses on avoid like waste production instead of treating it or clean it up after it forms. Then we have the atom economy. It focuses more like on maximize the incorporation of all materials using to the final product. It means that it doesn't has to have leftovers. The third one is less hazardous chemical synthesis, and it focuses on design synthetic methods that are like safer for humans and the environment in general, for animals, for plants, for every single live being. So then we have the fourth one that is designing safer chemicals. So create chemical products that are effective but have minimal toxicology. And the fifth one is safer solvent and auxiliaries, and focus more on use safer substances or not at all during production process. And the sixth one is about design of energy efficiency, and it's focused on maximum energy consumption by carrying out reaction at room temperature and pressure where it is possible. The seventh one, it says that it's use of renewable feedstocks, and when it prefers raw materials that are renewable over non-renewable. For example, we have the petroleum and the plant-based resources. It is preferred to use the plant-based resources because it is a renewable, renewable material. So the the eighth one, it is reduce derivates. So yeah, it means that it avoids unnecessary steps like blocking or protecting groups, which could create waste and use extra reagents. So the ninth one is about catalysis. So yeah, as you may know, a catalyst is a compound, an element that you could reuse. So in concept, it is a renewable source, and it is more efficient instead of like stoichiometric compounds or reagents. So the 10th one is designed for degradation, that is focused more on like design of product to break down into harmless substances after use, reducing like the environmental impact. And the 11th one is the real-time analysis for pollution prevention, and it is more like monitor chemical reactions in real time to prevent the formation of hazardous substances. The 12th one is the inherited safety chemistry for accident prevention. So it is focused more on the choice of substances and processes that minimize the risk of explosions, fires, or toxic gases. So then, as I said before, I'm going to focus more on polymers. In this case, we could see on the image or on the images that we have two polymers. That is the PLA and the PHP. As you can see, 19 days later, these polymers are like, they are degrading into the environment. And this is because the organisms like bacteria, they break it down into water or CO2 and biomass. You could compare it with plastic, with PET. So PET, it degrades very, 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 very slow. And and we could see that on the actuality on these times, we have like problems with microplastics. So yeah. Here we have a case of study, so I'm gonna say it like a little bit fast. Here we have the synthesis of the polymer. So yeah, first the polymer, we could see that our reagent is lactic acid, but how can I get that lactic acid from where? So first, natural sugar, like from corn or sugarcane, are fermented by bacteria like lactobacillus to produce lactic acid. This is a green process because it uses renewable resources and mild conditions. So the second step here is the polymerization of lactic acid. You could see like above that you have like the direct condensation polymerization. Sorry, yeah, direct condensation polymerization. So it is also called direct polycondensation. And well, lactic acid molecules are joined together like directly. And well, it releases water in the process. What is the problem with that? That the water interferes with that reaction. So as you can see, like on the chain, it is, yeah, well, it is like dispersed, like separate. So it is hard to get high molecular weight PLA. The second one, that is the preferred method, we use two lactic acid molecules that are combined into a small shaped molecule called lactide. So you could see there that like that small ring, yeah, it has like oxygen on like a para position. So yeah, and the process of the catalyst, we sometimes use tin. Again, we are using catalyst as for making it more like green. The lactic rings are open and link it back together into long chains of polylactic acid. So we use like tin to octanoids. Well, this method gives a stronger, high quality PLA. So it is more efficient. And well, then we have this, that is the usage. So I'm gonna see like faster. So you could see that that polymer is used on 3D printing. So industrial application of it, as I said, is 3D printing and packaging, such as this board of water, that you could see that it degrades very, very, very fast in comparison to PETs. It is also on biomedical devices and agriculture. So yeah, the challenges and limitations. Well, first is the cost. It tends to be higher than conventional plastic. You could see that it's sometimes, well, that is 2 times more expensive than conventional plastics. So that is like some limitation that we have there. Finally, we have the future overlook and conclusions. So, well, biodegradable polymers offer sustainable alternatives to traditional plastics, aligning with the principle of green chemistry. But we need like more innovations, such as new catalysts and microbial synthesis that could make more efficient or polymer. And we need to adapt to new industry. Even though we already have like some industries that are interested in that polymer because its properties. So, well, for me, that is my biography, and that will be all. So, thank you so much. Thank you so much. Have a good day.